Hey guys, welcome to week 4, lesson 1, geometry. In this lesson, we're going to specifically focus on area. Our learning target, so since this is my pre-AP class, y'all are actually going to have 2 learning targets. This first portion is going to cover the first part of the learning target, and then later on in this presentation, you'll get to the second learning target, which will cover assignment 2. So for assignment 1, our learning target is I can solve problems for the area of squares, rectangles, parallelograms, triangles, and trapezoids. Our criteria for success. First step, we're going to determine the shape. Second step, we'll locate the dimensions of the shape. Remember, the dimensions are going to be our base, our height, and our area, so our final answer. Step 3, determine which dimension is missing. Step 4, substitute in the known values into the formula. And step 5, calculate the unknown value. Remember, area is measured in square units. So when we're multiplying inches times inches, that's how we get to our inches squared. Centimeters times centimeters, centimeters squared, and meters times meters, meters squared. Now let's go back over our shape formulas. So for a square, we have area equals a squared. So a is going to be our side lengths. And we know that for a square, all the side lengths are exactly the same. So if we were to just do one of these side lengths, let's say it was 2, we would just have to do 2 squared. Because remember, 2 squared is the same thing as doing 2 times 2. Rectangle is going to be base times height. Remember, our base is our foundation. Okay, the base is always at the bottom. Our height is up and down. I want you to remember with the height, it's like we are taking the height of ourselves. Our height goes up and down. For a parallelogram, again, it's the same formula as a rectangle. It's base times height. Now remember, with the parallelogram, it can throw you off because sometimes they're going to put a number right here on this diagonal line. But think about height. When we take our height, it's not diagonal, it's up and down. So make sure you keep that in mind and don't let it confuse you. Now when we look at a triangle, triangle is base times height, but this time we divide it by 2. To calculate the area of a trapezoid. So the trapezoid, this is when we're going to actually have 2 bases. So we need to add up the length of base 1 and base 2. Then we'll divide that sum by 2. And then we'll multiply the quotient, so which was the answer to the problems we just did, by the height. So we'll add up base 1 plus base 2, divide it by 2, multiply that answer by our height. So let's look at a few examples. So this shape here, we have a parallelogram. Remember, our formula is area equals base times height. If we substitute in, we know our base, which is at the bottom, is 14, and our height is 7. Remember, this is where I told you don't get it confused because this is diagonal. This would not be our height. Height is straight up and down, not diagonal. So 14 times 7 would give us 98. So the area of our parallelogram would be 98 centimeters squared. Triangle. The formula for area of a triangle is base times height divided by 2. Now, if you take a look at this picture has a lot of numbers on it. So again, we're only looking at the base and the height. So the base is 2.8 and the height is 1.5. We don't need these other numbers right here. 2.8 times 1.5 gives us 4.2. We divide that by 2, which would give us 2.1. So the answer to the area of our triangle would be 2.1 feet squared. Now let's look at the trapezoid. This one has a whole bunch of numbers everywhere. Again, only look at the numbers we need. We need one base, a second base, and the height. These two numbers are not even needed. So base 1, 24, plus base 2, 22, would give us 46. Divide that by 2 would give us 23. Multiply it by 11, which would end up giving us 253. So our answer would be 253 millimeters squared. The rectangle. The formula for the rectangle is area equals base times height. Now remember, usually our base is down here, but we know that this length up at the top is going to be the same as our length at the bottom. So we know that our base is 12.5 times 6 of our height. 12.5 times 6 is 75. So the area of our rectangle is 75 inches squared. Now let's take a look at this in word problems. So what is the area of the triangle shown in square inches? Now take a look at this picture. What do you notice about this shape? It's turned on its side, right? So if we were to flip it up and down, we would know that this 5.5 would actually be our base and the 10 is our height. So then we could use our formula, base times height divided by 2 to figure out our area. So our base we had said was 5.5 and our height is 10. So 5.5 times 10 is 55. 55 divided by 2 gives us 27.5. So the answer would be D. The area of the triangle shown is 27.5 inches squared. Let's look at another one. Cheryl's design is created using trapezoids like the one shown below. The dimensions of the trapezoid are shown in the diagram below. What is the area of the trapezoid in square inches? So just like the other problems we had done, we know we need to plug in the numbers for the formula. So we have base 1 of 13, base 2, which is 8. So we know we have 13 plus 8 divided by 2 times 8, which is our height. Notice they throw in 7 here to try to throw us off. So 13 plus 8 gives us 21. And then 21 divided by 2 gives us 10.5. Then we need to multiply 10.5 by 8, which would give us 84. So the answer would be A. The area of the trapezoid is 84 inches squared. Okay, pre-AP, this is where we're going to have our second learning target. So these are specifically going to be for assignment 2. So I can deconstruct a figure into basic shapes and find the area of the total by adding them together. So this is composite figures. So a composite figure is a figure or shape that can be divided into more than one basic shape. So when we talk about the basic shapes, we're talking about the triangles, trapezoids, parallelograms, rectangles, and squares that we had actually just covered. The criteria for success is to calculate the area of a composite figure. First, we must decompose or break apart the figure into the basic shapes. Second, we follow the success criteria for finding the area of the basic shape, which was what we had just done. And then the next step that comes in is to add the areas of all the basic shapes that make up the composite shapes. So let's take a look at an example. Step 1. To calculate the area of a composite figure, first decompose or break apart the figure into basic shapes. So if we look right here, this would be our composite figure. Okay, so the area of this shape is actually going to equal the area of these two, because if we break them apart, we end up with a square, or well, a rectangle and another rectangle. Step 2. Follow the success criteria for finding the area of the basic shapes. So we know this is a rectangle, even though it looks like a square, it's a rectangle, because if we look at our two dimensions, they're different. So name of shape 1 is a rectangle. Area formula is base times height. So if we substitute these in, our base is 4, our height is 6, which gives us 4 times 6, which is 24. So the area of our first shape is 24 centimeters squared. Now we're going to look at the second shape. Again, we have another rectangle, so it's the same area formula, base times height. Our base is 3, our height is 2. So we would do 3 times 2, which would give us 6. So the area of our second shape is 6 centimeters squared. Step 3, we're going to add up the areas of those basic shapes that make up the composite shape. So we have 24 centimeters squared plus 6 centimeters squared, which would give us 30 centimeters squared. So the area of the composite shape is 30 centimeters squared. Let's look at an example. The figure below is made up of a rectangle and a scalene triangle. What is the area of the figure? So step 1, we need to decompose the composite figure into basic shapes. So we cut it into a triangle and a rectangle. We follow the success criteria for finding the area of the basic shapes. So notice back on this slide, on the first one, it didn't give us what the base of this triangle would be, but we know that this bottom length, or I'm sorry, the top length and the bottom length of the rectangle are both going to be the same, which is 20 feet. So that's where we get the base of the triangle from. So our base is 20, our height is 3. 20 times 3 is 60. We divide that by 2, which would give us 30. So the area of our triangle is 30 feet squared. If we look at our rectangle, we have our base of 20 times our height of 5.8, which would give us 116. So the area of our rectangle is 116 feet squared. Then we need to add up the areas of the basic shapes that make up the composite shape. So we need to add up 30 feet squared plus 116 feet squared. We would get 146 feet squared, because when you decompose the composite shape into a triangle and a rectangle, then add up the two areas, you'll end up getting 146 feet squared. So today we learned in the first part how to solve problems for the area of squares, rectangles, parallelograms, triangles, and trapezoids. Then we learned how to deconstruct a figure into those basic shapes and find the area of the total by adding them together. Remember, guys, it's super important. Area is measured in square units. Don't forget to put your squared with your answer. Please make sure to practice and have a great day.